Again, welcome everyone for joining this webinar for FeatureCAM and 5-axis features, as well as surfacing and tool axis control in your surfacing toolpaths. Again, my name is Oscar Romero with NextGen Solutions. I'm an applications engineer. My background here is going back about 30 years in the manufacturing industry. I've been with NextGen here for a little bit, and we this is a part of a series that we've created to give either current users or potential future users of FeatureCAM a little bit of insight into some of the functionality that's available in FeatureCAM. So what you're seeing here on your screen is a CAD model that I already imported into FeatureCAM. Now, in the past webinars, we've gone through and we've created some feature recognition, which, if you're not familiar with what that is, basically we've taken a CAD model and FeatureCAM is able to recognize some of the features around the CAD model. In this case, we have a CAD model that is mostly in a 3-axis format if you were to cut it from the top, this being the top face. But there are some other features that are not perpendicular to that z-axis from the top. So we have, if we take a look around the part, we have some holes around the side. Looks like we have a slot here, as well as a tilted hole and a tilted face to be cut. And so in this particular webinar, we're going to focus on creating features and toolpaths associated to those angular directions that are not perpendicular to a 3-axis. So there's some setup that we first have to do in FeatureCAM to be able to cut in 5-axis. Typically, when you import a part or CAD model into FeatureCAM, the standard orientation is going to be, or the standard setup is going to be for a 3-axis milling machine. Assuming that you've started in the milling environment in FeatureCAM. So that said, once you've imported your model and you've aligned your setup to the main orientation of your part, so how the part's going to sit in the machine, say on a vise or a fixture, typically that would be with some kind of orientation, say this being the top, and that's how we have it today. So again, to be able to reach some of these other features, we have to make sure that in our setup, we have a few different things applied. So I'm going to go back to the setup. And we're going to look here at what that might look like. So I've just created a setup one. It's got a G54. It's got the part name in it based off the CAD model. And then at the bottom here, we see a 5-axis position. Now, the reason why we see this 5-axis position, there's actually 4 different ways: a standard, an alternate, use a post preference if the post has some kind of preference already hard-coded into it, or you can use axis limits as well. Now, I'm just going to leave it in the standard for now. But there are other tabs here that will also allow you to do things like align your orientation to a stock face or a few other things, an existing user coordinate system or a part of the geometry on your CAD model. Now that's for the orientation of the main output work plane, your UCS. You also have the ability to go ahead and select your simulation machine file. In this case, we're just using a generic Mazak 5-axis table style machine. So once you get through that initial setup, we'll go ahead and cancel out of that because that's what we needed. We want to make sure that the stock is also modified so that we can get multi-axis motion. So again, as I mentioned earlier, typically when you start in a milling document, it will start in a 3-axis mode. You can specify when you go to the index tab in the stock that you'd like to use 5-axis positioning instead of the normal 3-axis or 4-axis. By the way, if you do want to do 4-axis positioning, you can select that instead. In this case, we're going to focus on 5-axis. Below that, you can also set your index axis limits. So if you prefer to stay within a range of axis motion for your A and C or B and C, you can select those here and apply them. You can also do operation ordering based off the tool or the setup as the dominant feature. Okay, so that means basically if you happen to be in an orientation with tool dominant, um, it will, if the same tool is being used in other orientations, it will go through and finish what it needs to with that specific tool around all of the axes that it needs to. If you have setup dominant, it will stay in one setup, finish what it needs to, regardless of how many tools are going to go through to finish the features, and then continue on to the next one. So I'll just leave this on setup dominant for now. But that's the gist of what you have to apply in the stock properties to make sure that you get the ability to create features in 5-axis positioning, as well as being able to get the output that you're needing from your post processor for those types of operations. So once we have the setup and the stock properties properly defined, we can then go to look at some of the features that we'll have to cut in multi-axis, and we'll get some of the 3-axis things out of the way first. So if you've never seen automatic feature recognition before, I'll show you here now what we can do with feature recognition. One of the two buttons here, either features or AFR, will go ahead and allow you to select the body. If you have multiple solid bodies in your project, in this case, we only have one, but if you had more than one, you could select them from the drop-down menu. Other solids might be part of the entire assembly that might be hidden away, but still in the same document, or tooling that you might have either around or under your component that you want to cut. Might be a vise, might be a fixture, but we do want to make sure that we select only the cut model that we want to identify for feature recognition. So once we have that selected, we can actually apply some different options to how AFR is going to look at some of the features. So if we select the options there, we can check on or off any of these boxes. We can identify a maximum hole diameter here. In this case, it's 1 inch. We can add a rough operation to any of our 3D features. And the 3D features, if they are created in AFR and they're recognized, you can select how those features are kind of put together. There's a few different options in FeatureCAM. You can have multiple features. You can have single features with multiple operations, or single features with single operation. So once you have this all as your preferences indicate, we just get out of that. We can go to the next step to select our setup. Now, in this case, we only have one setup created, so that's what it's going to choose. If we had multiple setups already created, then we can check on or off the boxes of the setups that we want features recognized in. So you can definitely create setups ahead of time, knowing the orientation of the different features, and then selecting them here in this list. Because we only have one, we're going to actually be looking straight down in the Z orientation from the top face that we mentioned before to find any features that are in that orientation and be able to create toolpath features for those. So a lot of these, if we look at the blue section here, a lot of these are recognized. There are some that we may not want to apply, possibly this surface mill type feature. Could be a few others here that we just don't want to recognize. Like in this case, there's a partial hole that's not being recognized properly. So I'm just going to go ahead and uncheck that. And I'll go through the list here. This one I want to go ahead and leave out as well because that's a partial hole. And I do want to make sure that I rough around this boss, this kind of angled boss here. So I'll leave that. And we do have a few other holes that were recognized along with their chamfers. Make sure I go through the rest of this list. Perfect. Now I can go ahead and finish that. FeatureCAM is going to automatically create those features for me. If I look in the browser, the whole features that are perpendicular to the Z direction have been recognized and they've been applied with several operations here over in the operations list. Now, there are a few, it looks like, that FeatureCAM did not find an appropriate tool for. So in this case, it's applying a half-inch chamfer tool to these holes here that happen to be a little bit larger than a half inch. So I'm just going to go ahead and select those. I can go in and reselect a new tool. I know I have a larger one, so I can just select a new one. Um, or I can modify the existing one. So I was under the impression that I did have one, but I'm actually going to go and double click to modify the one I do have now. So let's go ahead and select or make that 1 inch. We'll apply it so it's larger. Actually, I think we can do it with 3/4 inch. So let's go ahead and do that. And I'll rename it here just to make sure that we have proper identification. And the rest I'll leave alone. So I'll apply that, say, okay, I want to create a new tool instead of rename the original because I do want to keep the original and set it as the override for this particular toolpath. Apply it, and that should clear any of the errors that we're seeing in the operations list, and we should be able to run it. Now, again, this is for the all the features that are in the vector direction of Z, basically at the three-axis toolpath, and we can see the features there. They're not cutting away everything, so there's still some more work that we need to do. And that's going to require us to actually apply some multi-axis toolpaths. If we were in an environment where we had a table setup or a head setup, either way, we can tilt the orientation of the table or the head to align itself to these features, either on the angular face there, any of the other angular faces of the ramped kind of boss there. We have a slot over on the side as well as an additional hole over in the back side. So some of these things we can take care of right away by creating an additional setup. So the easiest thing to do is to create a new setup under the main setup, right? So for this one, basically what we want to do, and we'll just call this tilted face. I won't apply any other fixture ID than what is already there as default. We can just leave the 5-axis positioning as it is. And then here, we do want to make sure that we align to a part of the geometry. So in the drop-down menu, I'm going to select Align to Part Geometry, and I can simply select the face here by picking the Z direction. Click on our angled face. And I have the center of rotation down below the part. So this is where we're actually going to see what the Z direction looks like for what I just picked, that face, right? And if I'm happy with that, I can go and continue. If not, I can reverse the Z axis if that happens to come out in the opposite direction. But it looks like it's good there, so I can continue on, say okay, and you'll see that in my part view, I have the new setup there. Now, with that active, just go and deactivate our first one. I can then create a new feature. So first of all, I'll just select from our feature button here, and then we can select to create a face. Now I'm going to extract this with the feature recognition, and we can just select that face, add it. Go to next, and we can apply different operation properties there, as well as apply a different tool if we'd like to. This one's actually going to use a 3-inch face mill. And we can just go ahead and say finish. Now we can preview that and make sure that we're in the right orientation in the right location for cutting that feature. It looks like we are. So the only thing we have to worry about here is clearance, of course, because we're looking at the center of rotation being, I believe it's about 9 inches lower than the bottom of the part. But we can modify that either in the toolpath to make sure that we're going to go ahead and clear in the event of repositioning. And again, we can do that here in a location or dimensions. For now, I'm going to go ahead and go to the next set of oriented features. So we can do this slot, and this slot actually, we're going to go ahead and save that for the end because there is a surface style, a toolpath that we can apply that. If we look at this from the left side, the slot is actually, it has a draft angle on it as well as a radius at the bottom. So we can do a cleanup to kind of rough out that slot. And then we're going to come in with a swarfing style toolpath, show you how to apply a swarfing style toolpath. That's an automatic 5-axis along the wall to finish that feature. Before we do that, we do want to make sure that we can get some of these other features like the hole in the back and the hole there at the top. So we've already faced off the that larger surface, and we want to go ahead and recognize some of these holes that are at angles. Now, these two holes happen to be the same diameter. I just have that knowledge from looking at the model earlier. They have the same chamfer as well, but they're in different orientations. And so I want to recognize those features at the same time to just be efficient about my programming. And how we can do that is going into our feature creation button. We want to create a hole, and we want to do the extract with feature recognition here. So when we go to next, what FeatureCAM is going to ask us here is if we want to align to the setup z-axis, or if we want to align ourselves to a specific vector. Now, for the hole here, aligning to the current Z setup, because we are in the tilted face, would be just fine. We can do that one. But again, I want to be efficient, seeing these two holes that are the same size and have basically the same features. I want to go ahead and use the tools to do both of them kind of automatically. So I'll select along a specific vector, and I want to recognize all holes. Now, when I click next, I do have the option here to recognize and construct multiple holes. I can set again, a limit to the diameter, and I can also do merging of disjointed holes if I happen to have any. Next, it will search through all the features on the part, and it looks like it found all the ones that are perpendicular to our original setup and the one that's on the back tilted, but it didn't seem to find the one that's actually aligned to the axis of the setup. So for me, I would need to go ahead and take this back. So I'll go ahead and click on cancel. And the reason why we didn't find it is because it was aligned to that Z. So I'm going to go and reactivate my original setup. I'll turn off my tilted face setup, and I'll go through the same steps. So creating the feature, and I want to recognize a hole. I also want to use extract feature with feature recognition, and then go through the same steps. We're aligning to a specific vector here. We want to recognize all holes. And if we need to, we can apply some of the properties here for recognition. Now, what we see is a bit different. Now, oh, actually, no, we did get the same results here. What I was expecting to see here is getting this hole also recognized. It looks like for some reason it didn't do that one. So we'll go ahead and do this in a separate form. So what I want to do is uh, select that. I'm sorry, select this one here, not that, and finish. Looks like we need to drill here. So I believe that is a 600. Let's go search for that. Long way to go here. Okay, so we've applied a spot drill and the drill that's necessary to go ahead and cut that hole. We can preview it as well here. So we'll go through the steps of previewing our toolpath, make sure it's aligned properly, and it looks like it is. Let's go ahead and step back from that. Now we can come back to our tilted face orientation and complete this hole as well. So let's go ahead and do that. I'll do a feature, hole recognition, and we'll extract with a along the z-axis. So let's take a look at that. And one step back. Let's go ahead and pick a vector. So those two options did not work for recognizing the hole at the top that's at an angle. Now, this could happen from time to time where FeatureCAM doesn't recognize the orientation. So selecting along a vector and then picking the vector will help with orienting that. So let's go ahead and do that. Oh, there we go. So now we have the tool selected. It's interesting that the second time it worked. So let's go ahead and go along and finish that. Oh, I got to select both. Oh, geez, there we go. Let's go and finish that. And we have the two holes there recognized along in our initial setup. And I believe that was the trick, just selecting that one setup that's not oriented to either of the holes, which did the trick there. So now that we have the two holes here that have been created in two tilted orientations, we can go on to some of the other features. So again, I mentioned an automatic swerve style toolpath earlier. And that's what we're going to use here to create this slot feature. Again, I do want to make a new setup to orient myself to this face here. So I'll go ahead and do that and create a new setup. We'll call this slot face. And we'll make sure that we're aligned properly. So again, in the 0 tab, we'll select Align to Geometry. And we'll pick the top face of the slot. And let's look at our setup, make sure we're oriented properly. It looks like we are. Same orientation for the Z as the face is. If we wanted to, we can also pick a different X direction. In this case, I think it's fine, and it really doesn't matter too much, to be honest, because as we're going to post these, the only X direction, XYZ direction that's going to matter much is our original setup. So the setup at the very top. And then these orientations for the tilted face and the slot or any other features around the part are going to be automatically shifted in the post processor, and you'll get your output from the post processor for those. So really, we just need the Z orientation. The X and Y can be in any other direction that that gets applied. But if you're wanting to, you can pick a different X direction, right? So for instance, if I was to maybe post this setup on its own without having setup one or the tilted face setup active, and I just wanted to post this maybe for a multi setup orientation where this might be a 3-axis machine and I'm going through multiple vices to manually flip the part. That's maybe one of the scenarios that you may want to choose different planes to program your part, but not necessarily run them in a multi-axis environment. Today we're focusing on multi-axis, so we'll go ahead and leave the Z orientation as per the face and then the X direction as we're seeing it here. Select OK. Now I'm going to deactivate my first two setups and we'll focus on the slot face setup. Again, we do want to kind of clear out some of that material, so we can do that in two ways. In feature recognition, we can either create a slot or some kind of pocket feature based off curves. But I'm going to go straight to the swerve style. So I actually want to select to create a surface milling toolpath or feature. With that active, assuming that we've cleared out some of this stock or that we're okay with just doing it in the same operation, when we go to the next tab, we do want to make sure that we're picking the wall surfaces of the slot. So I'll get rid of the one there that just came up because I had the floor selected instead of the walls. I'll shift select just the walls of my slot, and I'll add them to my selection as the features that I want to cut. I'll go to next. And here, I could apply a roughing and a semi-finish and then a finish operation using the first option. But again, I just want to focus on the multi-axis portion of this feature. So I'll choose a single operation. And in the next dialog, we're going to see that we have many types of different surfacing toolpaths that we can apply. Now, each of these are going to have their own geometry that's more suitable for the type of toolpath we want to apply to it. And as you're going through selecting all of these, you get a small preview of what those might look like and how those may produce the toolpath trajectory. The one I want is this swerve toolpath here. And what that's basically going to do, it's going to take the geometry, and this has to be top rail and bottom rail of the surfaces that I choose. They don't have to exactly have the same shape, but the surface between them does have to be planar at the given point of the orientation of the tool. In this case, we do have a nice flat surface. There's no bulging, there's no gaps. So the end of the tool, the diameter of the tool can follow those surfaces very easily. Go ahead and select next. And here I can pick some options to first either reverse the tool axis if it happens to come upside down. I can also do this in the toolpath once I've already created it. I can ask FeatureCAM to go ahead and follow the surface laterals. So occasionally surfaces, when they're created in the CAD model, their lateral and longitudinal lines are not correctly aligned. So you want to be careful using the follow surface laterals, but if it benefits the tool trajectory, absolutely use that. The other thing is gouge checking. So because this is an automatic toolpath, the end of the tool has the potential to gouge the floor or any other part of the CAD geometry. So we want to make sure to apply gouge checking to make sure that we don't get violations of the CAD model with the tool. We can also add in holder clipping, and that's just going to check to the holder and the model to make sure that you're not colliding there. We don't happen to have a holder on this one, so we'll go to next. And this is automatically selected one of the tools for me, but I actually want to use a different one. This is some of the settings here are set to use a 1/2 inch tool by default, but I want to go ahead and change that. So I'll select search for another tool. And I believe I have a smaller 1/4 inch cutter here that I can use. I do want to do this with a bull nose, so let's make sure we have that selected first. There we go. And I'll select that tool. instead of our larger half-inch tool. We'll go through the steps and we can change or modify feeds and speeds, but in this case, we're just going to go with the defaults. We'll finish the toolpath and we can check it in preview here. So just to make sure that we're aligned properly, that the Z didn't come in upside down, that the toolpath's doing what it's supposed to do. I can go ahead and click preview and select a step through. And this is the automatic portion of the toolpath. Now, I didn't apply any other tool orientation than the setup, right? Remember, we aligned our setup to the face at the top of the slot, but this toolpath automatically aligns the tool axis to the wall or the surface that we've selected. Now, in this case, it looks like it's going, it's doing some conventional cutting. It's going to wrap around the part, and it's going to, again, it's going to keep that tool axis aligned to the surfaces that we selected. Trying to run this a little bit slower just so you can kind of get a good view in the preview, but well, maybe I'll run it a couple times because that's the slowest we can go. You can see how if I step through, the tool kind of goes through, and let me orient slightly here so you can see the tilt. It's about a 10 degree, 15 degree taper there, but it's going all the way down as far as it can go on the floor. And it's wrapping around the walls. This is going to give you the best possible, I believe, finish with the most efficient application of a toolpath. So we can actually go in there, we can machine surface that with a ball mill from the top all the way to the bottom, but obviously that's going to take many passes. It could leave some scalloping. And of course, we may want a nice finish on this. It's going to take the least amount of time. So applying a swerved, automatic swerve style toolpath here is, for me, the best option. Okay, now we do have this going in a conventional style. So I'm going to go and eject that simulation and come back to some of the settings. If we look at the settings of the swerve toolpath, the same options that we saw earlier when we were setting it up are available here. So again, if the tool axis happens to be reversed or in the wrong direction, we can reverse it here. We can still apply follow surface laterals. And then we also have other options here. For the 5-axis, this is an automatic toolpath. So it's automatically going to align itself to the wall surfaces. Again, the surfaces cannot be bulged. They cannot have gaps in them. If they do have spaces between the selected surfaces that you got or that you've selected, what will happen is that if they are machinable, FeatureCAM will cut as much as possible, and then between the gaps, it will raise and move over to the next possible cutting position, and then come back down into the cut the surface, and continue doing that if there's other gaps. So be aware of that. Uh, there are the other things you can do with multi-axis here, and we'll get to those when we start looking at some of the other features. But again, this one is automatic. You can apply tool axis, but be aware that because this is an automatic 5-axis tool path, applying tool axis limits that are less than what the tool needs to orient into the axis for the taper here may limit the tool path itself. So I'll take a quick look at that. Tool axis limits. Right now, the minimum and maximum for the elevation are -90 to 90. So it's pretty wide open. And the azimuth here, the azimuth angle is completely wide open. So I can go 360 degrees around the z-axis, and I can go -90 to 90 perpendicular to the z-axis. So again, I can apply limits here, but I'm okay with the tool tilting enough to do this entire surface all the way around. We'll see how that applies a little bit more in the other features. So there you'll find the tool axis control. And in the other properties here, we can define are typical properties that we might see in any other toolpath. So if we look at this dialog, we can do an axial offset. If the end of the surface happens to be hanging off the outside of the part, sometimes you want to go all the way down into a lower Z position in the axis orientation so that you don't get the flashing at the bottom or uncut surface that has not been removed. So you can use an axis offset to go lower or even higher than what the toolpath's giving you automatically. You can build in an axis tolerance, and you can also change the direction here. And this is where we were going here earlier. Right now, it's using bidirectional by default. And so just quickly there, I changed the bidirectional option to unidirectional, and I can choose from conventional and climb. Now, I was already in conventional with the bidirectional. So now I just want to make sure that I'm in the climb direction with the unidirection option on. I can also do things like change the way the Z clearance is set, any kind of output options, again, any other features where I may need to adapt. The other thing with this particular toolpath is fanning at the end of toolpaths, or I'm sorry, ends of the surfaces, as well as doing multiple cuts. So there may be a time when you cannot cut all the way down the side of the surface all at once. And so applying multiple cuts here and then choosing the type of merging you want from either the top rail and going down or the bottom rail and going up. Almost always I choose the one that has less maybe waviness or less change of direction. But if you choose the merge, that will kind of take the average of both the top and the bottom rail. So again, this surface is pretty consistent, but there are some instances where you have a higher or changing bottom or top rail. And so again, merge will kind of combine the average of both and give you passes that are um, in that kind of average center, right? And the same thing for offset from top and offset from bottom. If we choose offset from uh, bottom up, then it'll select the bottom rail. And if it's anything less than straight, then the axis, I'm sorry, the depth will change with that bottom rail, and vice versa for offset top down. So yeah, just to make you aware of that. And then again, fanning at the ends, you can do that just to kind of get out of the cut safely. You can also apply leads here. This is something that you want to make sure. If we go back to the milling side and we look at the preview, it will show that the lead in, there's no real lead in here. So we can actually apply different lead ins to make sure that we get a nice blend. We don't get any kind of markings or leftover material where the tool enters the tool path. And again, that's going to be in your retract and plunge, I'm sorry, your leads here. Currently we have direct, but we can use stair step or loop, and then apply those to the options here as far as when we want those applied. So if we choose, say, on all plunges and retracts, we have additional functionality that comes up. You can use ramp lead in and or lead in linearly for that. So I'll just go ahead and leave it the way it was by default. Come out of this And so that's a little bit about the automatic swerve style toolpath. Okay, that would have to be applied in surface milling. Now we're going to do the same thing to some of the features here um, on the ramp. So as I look at time there, we're kind of coming up on it. So we'll be able to get through some of these features um, on the radius. Let me go and hide away some of these other features so that we can clearly see the geometry on the part. We'll start with a parallel style toolpath, say for finishing this back face, assuming that we've gone ahead and roughed it out. Or we can apply a roughing toolpath because we do have some material left on that backside. So let's go ahead and select features. And again, we want to use surface milling. And we have the two faces already selected, so they're in our dialog and they're already added. We can go ahead and select the next. So again, the last time we just selected to create one feature. And this time we're going to go ahead and select potentially up to 3 different toolpaths for these two features. So we'll go ahead and go to the next. And this is the workflow for when you want to create a roughing operation for those features before applying the finish operation. So here we can go ahead and choose the tool diameter that we might want to use for roughing, a finish allowance, and then a tolerance for that. We can choose the Z-level roughing, classified as a 3D pocket or a 3D boss. There is another option here using plunge instead of Z-rough, but typically that's not a preferred type of operation. There are some applications that are useful using plunge, but we're going to stick to Z-level. By the way, if you wanted to completely ignore this first step, which is the roughing, and just go right to semi-finishing, you could select none and it would leave this operation out. So I'll take you through the rest of this. So we're going to do a roughing. And the next one is the semi-roughing or semi-finish, depending on how you want to look at it. And this would be applying a separate tool to get even closer to the finished dimension of the part before you actually finish. So this could be where you apply a parallel style finish, a semi-Z finish, or a finish in Z, right? So let's say we apply a parallel style. We'll go in the Y direction because I happen to know that this is oriented based off the setup. The feature's oriented in the Y. And we actually want to do this with a, say, 1/4 inch, well, I'll say 3/8 inch cutter. Now this will look through my tool library and it will identify any 3/8 inch cutters to apply there. And that's going to be used at number 2. It's going to be our semi-finish. Now the third here is going to be the final finish. And we have a lot more options here on how we want to apply that finish. The trajectory can be horizontal, vertical. We can apply a slope boundary, any kind of overlap between those when we choose horizontal, vertical. We can make it an isoline type finish, parallel, Z-level, or again, we can completely leave it out if we just want to apply a rough and a semi-finish. So any of those options can be applied. For us, we want to make sure that we do a parallel, and then we can refine the parallel toolpath as we go on into the next steps. So automatically, FeatureCAM has selected a 1/2 inch for roughing, 3/8 for our semi-finishing, and then looks like a 1/2 inch for finishing, but I'm actually going to change those because I want something a little bit different. So when we go to next, I'll leave the 1/2 inch for our initial rough. That's a 1/2 inch flat end mill. But for our semi-finish, I want to get closer to some of those bottom radiuses. So I'll search for a new tool, and oh, it looks like it did get a 3/8, but well, let's go ahead and leave that then. Say next. it's the finish that I want to make sure that I change because that's a half inch. It's definitely not going to reach into that bottom kind of radius that we have. So I'll choose a new tool. And I believe what we need here is something like a 1/4 inch tool. Select that. And then we'll go ahead and finish. So let's take a look at what we have here. Based off of what we've selected, we have a rough, a semi-rough, and then a finish, right? First one being a Z level, and then 2 parallels. If we preview the entire operation here, let's go ahead and do that. And hopefully it doesn't go too fast here. Yep, what we see is right now we have a bad orientation because we select, or I selected, to create these features with the orientation of the slot. So this is where things can go a little bit wrong if you don't have the proper orientation, I'm sorry, setup selected for this. I'm going to go ahead and stop here for now, and I'll come back. I'm going to go ahead and start this process over again. Let's see, delete that, and I'll make sure that I have my initial setup selected and the tilted off. So let's go ahead and do that one more time. Features, and we want to go surface milling, and we want to select our 2 surfaces, add them to our selection. Choose the 3 operations, our rough, our semi-finish, and then finally our finish. We'll make sure we have all the tools that we're requiring. So again, the last one, I want to make sure I change that to our 1/4 inch and reapply that. Okay, so as we preview now, we should get tools that are approaching from the setup 1 orientation. Oh, interesting. And we're getting a little bit something different. It could be that I did not first. Oh, looks like it just came in there. Let's shift that over. And we'll turn some of these off so we can simulate. Interesting. Okay, one more time. Let's go ahead and start that. Shifting it did not work. I was wanting to shift it. And let's try that one more time. Okay, setup 1. And we're going features, surface milling. We want to select our 2 surfaces here. Let's go with 1 for now, just so we don't go through that process too much more. So parallel, and we want to do finish in the Y. Okay. We'll go to next. Make sure that we have the appropriate tool selected. That would be a 1/4 inch. Now let's go ahead and preview that. There we go. Yeah, somehow the 3 operations was not allowing me. I believe it's just kind of got stuck in one of these 2 orientations, but this is really what I wanted to get as far as the orientation goes. So right now what we're seeing is a preview. Let me get this in a better view of our tool going from the bottom and coming right up the side of the part and also finishing that radius. Of course, I'll look back at that tool, and we may want to get one that's a little bit smaller, maybe this 625. Apply it, and we're going to do a little bit of different step over. So the step over distance is currently 0.05. We'll make that 10th thou. Set it, apply it, and then we can preview it again. So, of course, the desired finish is going to be up to you. That's how we can go and change the step over so we can get a finer finish. We applied a different tool so we can get down all the way into that smaller radius at the bottom. Again, assuming that we've gone ahead and roughed out the material, maybe semi-finished it as well, we can get something like this as a surfacing tool path. Now, of course, with a small tool like this, there may be times where your shank or the tool holder may be possibly colliding or nearly colliding, say, the top of a feature like that. So in a surfacing toolpath, we can apply multi-axis settings as well. In this case, we're in the main portion of the toolpath properties, but if we select parallel here, we do have a tab that will allow us to control multi-axis. Right now, what we're seeing is a vertical setting in this. Right, so now what I want to do is I want to use one of the other options here. So I can choose from a fixed vector direction. If I know the vector that I want to use, I can set it there. I can use a lead lean direction, and this is probably uh, the most straightforward to use, the easier one to understand. In lead lean, we the default option here is for the contact normal. So basically, if I leave it in contact normal, let me go ahead and apply that, and I can show you visually. My tool is basically going to align the tip, or actually the tool orientation, the vector, normal to the surface at any of the contact points. So let me get this in a side view here, and we can kind of zoom into the orientation of the vector of the tool. And then I can run through the entire simulation. And as we're going, you can see some of the edges there of each of the surfaces. The toolpath is currently set to kind of roll over those edges, but you'll see that also on the top. As we start changing vector, it's kind of staying normal to the surface. At the ends, this is kind of what we're seeing. So obviously, this is probably not the most desired uh, way to cut this. It's going to violate the surface, and that's not really what we want. So making some changes to that and possibly changing the way edges are recognized. So right now it's automatic, but we can have it not roll over the edges. And this would help us here with staying, and it happens to go a lot faster this time around. So even though we are getting that tilt, let me show you this version first. We're not getting that tilt over on the edge. We are getting tilt that's going along the surface curvature, and that's normal. In other words, that's the normal five-axis control, right? So lead, lean, contact normal, but there are different options. We can keep it vertical and then apply a lead or a lean angle. In this case, if I wanted to do something like 15 degrees from vertical, I can apply that. And let's look at our side view again and zoom in a bit. Here is where we get a little bit different control over the actual tilt of the tool. So right now we're doing 15 degrees, and this is going to require a little bit of retract because of the orientation of the tool. But basically, that's what we get. A little bit more granular control over the tilting instead of allowing just the software to decide what the either normal direction is going to be. But there are other options we can apply the direction of travel. In this case, there's also a version of the toolpath that's kind of a earlier version, a legacy version of the way lead lean is applied. I do want to be conscious of time. We're running up to the end of the webinar here, so I'll just kind of go ahead and finish off with there's a few other options you can use to control the tilt orientation, and those are here in the other radio button options. So there's a lot here. You can actually control your tool orientation from a point to a point, from a line to a line, a curve, point, and so forth. So some of these are kind of just legacy versions of the way that functionality worked, and then you have some newer versions. So for instance, in this case, if I wanted to control my tool orientation with a point above the part, that would be from a point. And basically what would happen is that the tip of the tool would follow the surface, and at the top, my point would control the tool axis. And the same thing goes for curve or line. So there's a lot of functionality here for multi-axis and surfacing and five-axis toolpath control or tool axis control. But you can also add in tool axis smoothing to make sure that those orientations don't come with an abrupt change of direction. And it kind of helps to smooth out the tool axis motion, at least the code output for the tool axis motion. There are some options for gouge avoidance here as well, and you can choose to have no tilting, or you can choose one of the other options here as well. So you can kind of combine how you're orienting the tool, but also you can add additional functionality guided by geometry, whether it's a line, a curve, or a point, to any gouge avoidance, any automatic gouge avoidance that happens. So kind of as a second option. Again, you can add tool axis limits here. So if you're worried about maybe over rotating like we had at the ends, we can add a tool axis limit to that, and that would definitely control how far the tool can tilt to avoid any kind of collision with the part uh, or the machine to your shank or your tool holder or the head of the machine. Now, again, I do want to be conscious of time, so that kind of wraps it up for us. If you'd like to know more about multi-axis machining in FeatureCAM, or if you're completely new to FeatureCAM and you need maybe some training on these features or on this control, definitely reach out to us. You can find more information at nextgensolutions.com or info@nextgensolutions.com if you want to go and email us. This recording is also going to be sent out to everybody that joined our webinar today, and you'll get more information on how you can contact us for that. So if anybody wants to do so, feel free to contact us, and we can get back to you on any questions you might have. Again, thanks for joining. Appreciate you all. Again, my name is Oscar Romero from NextGen Solutions, and have a good rest of your day.